Hello, welcome to Clee. Today we will introduce how to create a boss with a state machine. Bosses can be seen in different game mechanics, like an MMORPG dungeon guardian, important villains in the storyline, or the elite enemies players meet during exploration. These boss battles can be managed by the state machine. So what is a state machine? A state machine is a behavioral model that consists of a finite number of states, such as a character having the walking, jumping, fighting, sleeping, and death states, which can be switched. For example, when the character is walking and meets an enemy, he will switch the state from walking to fighting. Let's take a look at the states of the boss we designed in this lesson. The boss is in the sleep state at first. If the player is near the boss's alert area, the boss switches from sleep state to battle state. When the boss's health is halved, it will enter the transformation state. Both appearance and skills of the boss will change. The boss can heal by hitting the player in the transformation state. When it heals a certain level of HP, the boss switches back to the battle state. When the player dies, he will revive at the initial position and continue the battle. The player can get a reward after killing the boss, and death is also one of the boss states. First, let's do a quick breakdown of the project. From the demonstration, we can recognize the 4 states of boss. State 1, sleep. State 2, battle. State 3, transformation. State 4, death. At the beginning of the game, the boss is in State 1, sleep. When the player enters the boss's alert area, the boss enters State 2, battle. During the State 2 battle, if the boss's health is lower than 50%, it will enter the State 3 transformation. At State 3, the boss can heal by hitting the player. When its health reaches 100%, it will turn back to State 2. No matter the boss is in State 2 or State 3, if the player leaves the alert area, it will turn back to State 1, sleep. The best time to kill the boss is State 3 when the boss is in the weakest state. If the player successfully kills the boss, it enters State 4, death. If the player dies, revive the unit until the boss is killed. After the state analysis of the boss, we can break down the implementation process into 4 parts. 1. The judgment and execution of State 1, sleep. 2. The judgment and execution of State 2, battle. In this state, the boss used skill 1 to fight. 3. The judgment and execution of State 3, transformation. In this state, the boss transforms and uses skill 2 to fight, and gains health after hitting the player. 4. The judgment and execution of State 4, death. Now, let's make these mechanics happen. Now, let's see how to achieve these functions. Before creating the boss, we set up some initializations for the future process. Set a unit global variable to store player units. Set a point global variable as a player's initial position point. To prevent the player from selecting another unit by mistake, we turn off the click and drag selection, then select the prepared unit for the player. For a better game experience, we set the player's camera to follow the player's unit. Since the boss has multiple states, how do we make it switch to a specific state under certain conditions? We can tell the boss by sending and receiving custom events. For example, a customer will press the service bell when he needs to order, like sending an event to the waiter. The waiter only comes to the customer when he receives the event. instead of him keep asking every customer if they are ready to order. Similarly, we click on Event Management in Quickly and set up 4 custom events for the game: Sleep, Battle, Transformation, Death. When the boss needs to switch to a certain state, we send a specific custom event. For example, when the game starts, the boss should be at sleep state, so we send it a custom event, Sleep. Let's take a closer look at the first part, Sleep state. When the boss receives a sleep event, perform the sleep state actions. Let's set a unit local variable to store the boss unit. To simulate the boss is sleeping, we make the boss play idle 1 animation. Set a Boolean local variable, bool, to switch the boss state. False represents the state is unchanged, and true is otherwise, so the variable is initially set to false. We then use a timer loop to check if the player unit has entered the boss's alert area. Use the if statement to determine whether the position of the player unit is in the boss's alert area. If the condition is true, switch the boss's state to battle, set the Boolean variable to be true, and send the battle custom event. If the condition is false, no action is taken. Then, we continue to monitor whether bool equals true. If so, it means that the state needs to be changed, so we delete the current timer and the boss unit. Otherwise, no action. Here is the first part, the implementation of the boss sleep state. In addition to the loop structure, we also use 2 selection structures for conditional judgment. You can try it out during the practice time. We will show the suggested solution after that. Let's take a closer look at the second part, battle state. When the boss receives the transformation custom event, it will perform the actions of the battle state. Set the local variable unit boss to store the boss unit. To let the player intuitively feel the state change of the boss, we add a magic effect for the battle state. Set a local variable bool as a state toggle, initially assigned false. Set an integer local variable CD to record the battle state skill CD. We then use a timer loop to check if the player's unit is alive, in the alert area, and if the state toggle is turned on. Let's first determine if the player unit is alive. The boss fights only when the player is alive, or it will do nothing. During the battle, set a float local variable proportion HP to store the result of the boss's current health divided by its maximum health. Then determine if proportion HP is more than 0.5. If so, it shows the boss is not in danger, so it will keep using skill 1 to battle. If the boss's health is lower than half, it should switch to the transformation state. We set bool as true and send the custom event transformation. The boss's skill has a cooldown time. The CD will accumulate until reaching a certain value, which means the skill can be used again. Let's set the cooldown length as 50. When the CD reaches 50, the count resets to 0 and the boss casts a skill. Before that, no action needs to be taken. The skills here can be encapsulated in the function library to be reused in other games. Here we design a fire skill, but you can set it according to your own preference. The boss skill is casted at the random point in the alert area, so we need to set a point variable as the parameter to represent the point where the skill is cast. We then create a fire warning projectile to warn the player the future explosion at this location. Set the warning time to 3 seconds. After 3 seconds, create the projectile of the flame explosion. Check whether the player is near the skill cast point. If so, deal real damage to the player. Otherwise, no action. After monitoring the player's survival, we monitor if the player unit is in the boss's alert area. If it is still in the alert area, no further action. And if the player unit leaves the alert area, the boss should return to sleep. Turn on the state toggle bool to true and send the custom event sleep. Finally, we need to determine whether the state toggle equals true. If so, delete the timer and the boss unit. Otherwise, do nothing. The above is the second part, the development of the battle state. You can try it out during the practice time. We will show the suggested solution after that. Let's take a closer look at the third part, transformation state. When the boss receives a transformation event, it will perform the actions of the transformation state. To let the player intuitively feel the transformation, we change the boss's model. Then, set a unit local variable, unit boss, to store the new unit. Beware that in the transformation state, the boss's maximum health is left to a half. We can also add a magic effect for the boss to strengthen the visual performance of transformation. Similar to the battle state, we need to set the toggle variables bool and skill CD. Use a timer loop to check if the boss is alive, if the player unit is in the alert area, and if the state toggle is turned on. Let's first determine if the boss is alive. If the condition is true and the boss is alive, then we should determine whether the player unit is alive. If the condition is false and the boss is dead, it should switch to the death state. So we send the custom event death, passing a parameter of the death location point. Similar to the battle state, the boss only fights if the player unit is alive, or it will do nothing. We use the variable proportion HP to store the result of the boss's current health divided by its maximum health. Then see if the result equals 1. If so, the boss restores all health and switches to the battle state, which means we set the bool toggle to be true and send the custom event battle. Otherwise, the boss should use skill 2 to fight the player. Similar to the battle state, the CD accumulates itself, and until 50 to make the boss cast a skill and recount. No other thing happens in this process. We still use the function library for the skill 2. Let's set a lightning skill for the transformation state, which you can change according to your own preferences. First, we set 2 parameter variables, a point variable for the skill cast point and a unit variable for the healing target. The skill 2 can recover the boss's health if it hits the player. We then create a lightning warning projectile to warn the player the future explosion at this location. Set the warning time to 3 seconds. After 3 seconds, create the projectile of the lightning explosion. Check whether the player is near the skill cast point. If so, deal real damage to the player and heal the boss. We can also create a projectile for healing event. Otherwise, no action. After monitoring the player's survival, we monitor if the player unit is in the boss's alert area, and if the toggle bool is true. This is the same logic as the battle state, so we skip the repeat explanation. The above is the third part, the development of the transformation state. You can try it out during the practice time. We will show the suggested solution after that. Let's take a closer look at the fourth part, death state. The death state of the boss is simple. Receive the custom event, then perform the actions. To intensify the player's sense of achievement for defeating the boss, recreate some coin projectiles to indicate it is a great success. Finally, if the player unit dies, revive it at the original point. Now that the functions are completed, let's get into the game and test it out. Now, it's time to review what we learned today. In this lesson, we learned what a state machine is and how a character can switch between multiple states. Then, we analyzed the behavior of the boss in various states: sleep, battle, transformation, and death. During the analysis, we learned about sending and receiving custom events, as well as the skill of function encapsulation. You can freely design and switch each state in a state machine. Even add a second layer, like how we gave the boss a transformation state based on the battle state. Enrich the boss's performance. The state machine can also be used on the player unit, especially in ACT games, to achieve game effects such as combo, super armor, and so on. Hope you enjoyed this video. See you next time.